The purpose of this video will be to provide solutions to these practice problems. I'm not going to take too much time with each one, but just briefly mention the types of thinking that I'm going through. For the first one, as any problem with dimensional analysis, I'll start with my unit over 1. I then think about whether or not I know a direct conversion from kilograms to pounds, and I do. So with dimensional analysis, if I want to cancel out kilograms, I will multiply by a conversion factor with kilograms in the denominator, and like I said, I know there is a direct conversion from pounds to kilograms. There are 2.2 pounds in 1 kilogram. That tells me if I multiply 2.2 times 6, which you will get 13.2, and the numerator, that's the numerators. The denominators, 1 times 1 is 1. This gives us 13.2, and our unit is pounds. For the next one, very similar. I'm starting with 20 kilograms. So now I'll write 20 kg over 1. Just like with the last one, I know the ratio here. There are 2.2 pounds in 1 kilogram. So just like the last one, if you multiply 20 times 2.2, you're going to get 44. There are 44 pounds in 20 kilograms. For the next one, 6 ounces to milliliter. I notice that this is a measure of volume, milliliters. That means I'm going to be working with fluid ounces. Immediately you should know then that we're not worried about 16 ounces in pounds. We don't need to think about the ounces associated with weight. Do you know a direct conversion from ounces to milliliter? You should. You should know that 1 fluid ounce is 30 milliliters. Now from here you might be able to see you just multiply 6 times 30. But if that's not so clear, once again just set it up with dimensional analysis. I'm starting with my unit over 1. I'm converting ounces, so I need to cancel out ounces and go directly into milliliters. I know there are 30 milliliters in 1 ounce. If I multiply by 30 over 1, ounces will cancel. You should get 180 milliliters. The next one, very similar, 50 milliliters over 1. I'm canceling out milliliters and I'm going into ounces. I know the conversion here. 1 ounce is 30 milliliters. So I'm going to get 1.7, approximately 1.7 milliliters. This is 50 times 1, and then you're going to divide by 30 times 1. So 50 divided by 30, we round that to the tenths place, about 1.7. For the next one, teaspoons into milliliters. This is a direct conversion. There are, if we wanted to take out teaspoons and go into milliliters, 1 teaspoon is 5 milliliters. So teaspoons would cancel. That would convert into milliliters. You should get 20. For the next one, it's a little bit more complicated. You may not know a direct conversion from liters to tablespoons. I do know, in order to get to tablespoons, if I knew milliliters, I could get to tablespoons. I know that there are 15 milliliters in a tablespoon. So if I can just go from liters to milliliters and then milliliters to tablespoons, I'd be good. So this is the dimensional analysis that I'll do. I'm mapping this out first. So I'm first just going to set up my units. If I multiply by a conversion factor of milliliters over liters, liters will cancel. But then I want to cancel out milliliters and go into tablespoons. So I'm just setting everything up. And now I'm going to go in and put in my conversion factors. I know in 1 liter there are 1,000 milliliters. And I know there are 15 milliliters in 1 tablespoon. So what am I going to get? In the numerator, I'll have 1.2 times 1,000 times 1. That's 1,200. Right? This is just multiplying the numerators. In the denominator, I'm going to get 15. So I'm going to have 1,200 divided by 15. You should get 80. 80 tablespoons. The final 2 problems, I'm going to use the formula Fahrenheit equal to 1.8 times Celsius plus 32. I need to solve for Celsius in this example, so I'm going to plug in 98.1. I'm going to plug that into F. 98.1 is equal to 1.8 times Celsius plus 32. So think about what we would need to do to get the Celsius by itself. If we knew Celsius, we would have multiplied it by 1.8 and then added 32. So let's work backwards. Let's subtract 32 first. Right? We're going to subtract 32 first. So 98.1 divided by 32. This is 66.1. And now let's divide by 1.8. You're going to get approximately, when you divide by 1.8, you're going to get the Celsius is approximately, if we round this to the tenths place, 36.7 degrees Celsius. Now this is the formula that I just used, but you could use the other formula on your conversions to memorize. If you take Fahrenheit, subtract 32, and divide by 1.8, you're going to get Celsius. And you notice that's exactly what we did. We took the Fahrenheit here, we subtracted 32, and then we divided by 1.8. The final problem, 11 degrees Celsius, I'm going to plug that into this formula. So I'll take 11, I'll multiply it by 1.8, and then I'm going to add 32. So I can do all of this at once. Your calculator, if you put that entire thing in, it should do the order of operations correctly. You're going to get 51.8. If you have questions about these problems, let me know.